Army Patriot missile connects with Air Force F-35 to destroy cruise missiles. Imagine cruise missile threats streaming through the air toward multiple vulnerable targets. As that happens, radar nodes light up across a wide-spanning territory as an airborne F-35 senses the attack. The stealth fighter then hands off targeting data to ground-based U.S. Army Patriot interceptor missiles, knocking the approaching missiles straight out of the sky and destroying the attacking threat. The Missile Defense Agency is particularly interested in using F-35s to spot and potentially shoot down enemy missile launches. The Air Force Chief of Staff General David Goldfein has called the F-35 a computer that happens to fly, and sees it as a central node in the joint multi-domain command and control network he's determined to construct. This kind of warfare development, wherein multiple sensor nodes track and share information across domains to identify and destroy threats, represents the exact intention of the Army's Integrated Battle Command System, IBCS. IBCS is a fast-emerging technical system engineered by Northrop Grumman to network radar and sensor nodes throughout wide-ranging air, ground, and sea operating environments as a new interwoven or meshed air defense network. IBCS is in theory the ability to link multiple sensors to an air defense system. Right now, if a defense system is a Patriot missile, you have a Patriot radar. If it's a THAAD, Terminal High Altitude Air Defense, it has a TPY-2 THAAD radar. We've got several radars for different systems. IBCS brings the ability to take any sensor and link it to just about any air defense system, to include some of our artillery sensors and counter-fire sensors, General John Murray, Commanding General of Army Futures Command, told Warrior in an interview. Northrop recently issued a report about a previous IBCS test demonstration wherein an airborne F-35 fighter jet used its sensors to acquire, track, and share target data with ground-based radar, enabling an integrated air defense system to establish a continuous track of the attacking weapon and therefore identify the proper defensive weapon or interceptor missile to destroy the threat. High above White Sands Missile Range, an Air Force F-35 tracked 2 surrogate missiles in the test and sent the sensor data to Marine Corps TPS-59 radars, an Army Sentinel, and Patriot ground-based weapons. As one sensor loses sight of the threats, and each will at some point, the targets are acquired by other sensors on the ICBS Integrated Fire Control Network. The weapons operator sees every change in altitude and direction as the 2 surrogate missiles painted tracks across their screens, a Northrop statement says. This kind of operational use for the F-35 fighter jet represents an interesting manifestation of a part of the vision for the F-35, namely that as a multi-role fighter, it can function as an air-ground attack platform as well as an aerial sensor node able to perform drone-like ISR missions. The aircraft's distributed aperture system, for example, combines electro-optical sensor data from 360 degrees surrounding the plane. The data is aggregated and organized for pilots by onboard computer automation, performing what's often referred to as a sensor fusion function. The F-35 uses an electro-optical targeting system in conjunction with the distributed aperture system and a database of known threats called mission data files to find targets. This means that when it comes to operations, an F-35 could use its long-range sensors to detect a threat object, bounce the data off of a previous existing database of known enemy assets, and instantly determine what kind of threat might be approaching. This performs a rather substantial combat function, as it could enable an F-35 to cue ground-based radar and air defenses about specific enemy attacks from long ranges beyond the horizon. Murray explained that this kind of integrated sensor fire control network brings new dimensions to a heavily emphasized strategic approach for the Army and the Pentagon, multi-domain operations. Longer-range weapons and increased adversary air-ground-sea coordination present an entirely new sphere of threats. An F-35 could, along with nearby drones or even satellites, track warfare information and network with surface ships or ground-based artillery. As one senior Army official once described it, when it comes to artillery, it doesn't matter if the target is on the ground or at sea. meaning that ground-based weapons can launch maritime, ground, or even air attacks all in coordination. A multi-domain operations concept will transition into a new doctrine to replace air-land battle, a Cold War air-ground attack doctrine. A concept is a concept because you don't yet have all the tools to execute it. So there are certain things related to operations that we don't have yet. It's important to think about what comes next. If technology continues to evolve at the rate it's evolving, and there are indications that it's going to, you have to look out into the future. If you don't start thinking about it, it's going to be here before you know it, and you're going to be behind, he said. The F-35, with its advanced sensors and connectivity, is able to gather and seamlessly share critical information, Lockheed Missiles and Fire Control, Scott Arnold said in a statement. This demonstration represents a significant growth in capability for the Army Integrated Air and Missile Defense Program and multi-domain operations. This is another example of the power of IBCS open architecture design, which enables the integration of any sensor to any effector in any domain, said Northrop Grumman's Dan Verweel, Vice President and General Manager. Any sensor, any effector, any domain. This is the future of the U.S. military's fight.